How do we do this new way of dividing? Let's find out. First, it's not really new, it's just different than long division. So the goal is asking ourselves how many of the divisor fit into the dividend, and we're using what we know to help us. So how many 4s fit into 136? Well, someone can say, well, I know 25 4s is 100, I think that's a good start. So we used up 100 out of the 136, so we're left with 36, and we repeat the question. How many 4s fit into 36? 9. And 9 times 4 is 36, and when we subtract, we're left with 0, so we're done. So to obtain our answer, we just combine what's on the right. So we see that 136 divided by 4 is 34. And what's great about this method, called partial quotients, is that there are many ways of getting the right answer. For example, someone else could have done it like this. And we can also overestimate with this method. Someone can say, well, I know 40 4s is 160. Oh wait, I went over by 24, so I need to take away 6 sets of 4. We still get 34. And this is what it looks like when there's a remainder involved. We can say that the answer is 34 and 1/4. Or we could say a fourth times 4 is 1. When we subtract, we're left with 0. So when we combine, we get 34 and 1/4. Now, a strength of partial quotients that I really appreciate is that we get to see the dividend as a whole number, rather than 1 or 2 digits at a time like we do with long division. And when we see it as a whole number, we can use what we already know to help us. So we can do long division over here, or we can say, well, I know 20,000 5s is 100,000. Oh wait, I went over by 1 5. So the answer is 19,999. Now, I know someone in the comments is going to say, okay, well, do this method with this big number divided by 137. And I would argue that at a certain point, we would just use a calculator. Now, long division is still being taught. It has an advantage with decimals. But if the goal is number sense, I really like partial quotients.